Good morning, children. Next theorem, theorem 8.10, converse midpoint theorem. So midpoint theorem last class we have seen. Now we have to study about the converse midpoint theorem. So the line drawn through the midpoint of one side of the triangle parallel to another side bisects the third side. So in this statement itself you can see that all the three sides have one or the other duty. What is that one? One side of the triangle, the line drawn through midpoint of one side parallel to the second side bisects the third side. So this bisects the third side only we have to prove now, right? So for that, what are the conditions is given? We have to draw the line from the midpoint of one side and also parallel to the second side. If these two conditions are satisfied, then naturally it will bisect the remaining side. So let us see the diagram now. Triangle ABC we have drawn here, and we are taken as E is the midpoint. Got? And from the midpoint we have drawn a line which is parallel to the second side. So first side what we have taken? Midpoint, that is E. From E we have to draw a line parallel to the second side. So let me complete the line, that which is the line EF. EF is the line which is parallel to the second side. See that EF is parallel to second side. So these two conditions are given. If it is midpoint, I can write like this: AE equal to EB. See the letter A. E equal to EB, the midpoint. Now what is the second part of that one? EF parallel to BC. Then this line segment bisects the third side. That means if this is meeting the third side at F only, so it should be bisected. That we have to prove. I cannot mark now, that is to be proved. So what is the meaning of that one? We should get AF equal to FC. That means the line segment meeting at the third side at F only, F is bisecting AC. AF equal to FC we should get. The same way we have to do the construction. So what is the last construction? We have to draw the parallel line CM to BA. So let me write what is given in the question. Given in triangle ABC, E is the midpoints. Like last time midpoint theorem, we will write AE equal to EB and EF parallel to BC. These 2 points are given to us. To prove it bisects the third side, that means AF equal to FC we should get. Construction. What is the construction? CM parallel to BA. Still it is not completed. CM parallel to BA. Again, what is the next one? Extend EF to meet CM at D. Extend EF to meet CM at D. So I'll complete this line. So EF also we are extending here up to D. Again, what is this parallel property? This CM parallel to BA. So I'll mark here also parallel, and what is the here? Here also parallel, right? So we got CM parallel to BA by construction, right? So these two are the construction steps. What are the same as last time? CM parallel to BA. Again, extend EF to meet CM at D. Okay. So now we can go for the proof. Okay. Now you see the steps now. Already EF parallel to BC, right? EF is extended, that means ED is parallel to BC also. So I'll write here EF parallel to BC given, and we have extended by construction. So EF became ED for us. ED parallel to BC. Again, that is a given property only. Now by construction, CM parallel to BA implies CD parallel to BE. So by construction, this one. So one by given, another one by construction. So can we write BCDE is a parallelogram? Check that one. See, BE is parallel to CD and EF parallel to BC we got means ED is also parallel to BC. So two lines are parallel, two pair of opposite sides are parallel. So what is the conclusion? BCDE is a parallelogram. If BCDE is a parallelogram, then what you can say about BE and CD? BE and CD are also equal. We can say that BE equal to CD. If BE equal to CD, can we write AE equal to CD? What is the reason for this one? AE and BE are equal. Equation number 1. AE equal to BE given. That is the reason for this one. Now again we will take which triangle? The same way how we have proved the last theorem. So triangle AEF and triangle CDF. Okay, the first one we will write as usual, angle F is equal to angle F vertically opposite angle. Next, now we have proved that AE and CD are equal, so I'll write here AE equal to CD using 1. Okay, so now you tell me, we have marked angle F equal to angle F and the side we have taken AE and CD only. So now we need included angle means we will not get a side also will not get a. So what we should take, one more angle we can hope that one we can take it as angle E, because when we are saying that this is a parallel lines. Okay, this is also parallel lines only. So what we can say about angle E and angle D? Both are parallel lines. Here also parallel line we are having and here also parallel line we are having, right? So these two angles, angle E and angle D, what you can say about that one? That is also alternate interior angle. Let us see the diagram where we are getting this at the. So if I start from AE, we have taken this triangle AE and up to D, then C. So are you getting a Z shape there? Okay, so we are getting E and D as a alternate interior angle. So we can write here angle E is equal to angle D, alternate interior angle. So what we can write? Triangle AEF is congruent to, triangle AEF is congruent to which triangle? So E equal to D only, so the middle letter is D. Angle F equal to F, so the last letter is F. So D and F is gone, so the first letter became C, so triangle CDF. So criteria is what? Two angles, one side, but the side is not included. So AAS, right? So we got AAS criteria. These two triangles are congruent. So what you can say about AF? AF equal to CF by CPCT. So hence proved. So once again the proof, what we have done here, triangle ABC is given. So E is the midpoint here. So what is the concept behind here? AE equal to EB. From that E, we are drawing a line in such a way that that line is parallel to the second side of the triangle. So what is the concept says that then it bisects the third side also. So we had given AE equal to EB and EF parallel to BC. We have to prove AF equal to FC. AF equal to FC. For that, what we have to do? We have to draw a parallel line, that is CM parallel to BA. If CM parallel to BA means this side is parallel, this pair of opposite side is parallel. Already by given part EF parallel to BC, so EF we are extending, that means this is also parallel. So two pair of opposite sides are parallel here. So what is the conclusion? BCDE is a parallelogram. Check here. BC parallel to ED we got, then BE parallel to CD we got. So two pair of opposite sides are equal. The reason is different. For the first step it is given, the second step it is construction. So by this result we got it's a parallelogram. If it is a parallelogram, we can say that opposite sides are equal. So BE equal to CD. But BE is also equal to which one? AE. So AE is also equal to CD, equation number 1. Now which are the two triangles we have to consider? The opposite triangle only. It's like last theorem, that is triangle AEF and triangle CDF. So angle F, vertically opposite angles, angle E and D, alternate interior angle. Now one more side we required, that is here we have done in the step 1. So AE equal to CD. So by using this you got two angles and one side. So triangle AEF congruent to triangle CDF AAS. So what is from this, what we can write? AF equal to CF CPCT, hence proved. Meaning is that F bisects the third side. So triangle PQR is given. What we learned from the theorem we can understand one more time with an example. PQR is a triangle and I had taken that L is the midpoint of PR. L is the midpoint of PR and LM is parallel to PQ. LM is parallel to PQ. Then what you can say about M? M bisects QR. Got? L is the midpoint. So we are starting from a midpoint of one side and parallel to the second side. Then what you can say about M? M bisects QR. That means QM equal to MR. Now I'll complete this one, that is from the M I am starting. So M is the midpoint now. So let me take like this. M is the midpoint. Now I joined with another midpoint here N in such a way that MN is parallel to PR. MN is parallel to PR. Then what you can say about N? N bisects PQ. What you can say about N? N bisects PQ. That means if the total length is 7, it will be 3.5 and a 3.5. Got? So now I'll complete NL. So NL is parallel to which one? QR, and N is the midpoint we have already done. So what you can say about L? It bisects the third side PR. That means when it is starting from a midpoint of one side of the triangle and parallel to the second side of the triangle, then it bisects the third side. Both the theorems have its own applications while solving, while doing the problems you will come to know. So I think you got the idea for proving the theorem. So what is this one here? What is the statement says? The line segment joining from midpoint of one side parallel to the second side bisects the third side. Again from here, L is the midpoint of the first side of the triangle. LM parallel to the second side of the triangle, that is PQ. In that is the case, if that two conditions are satisfied, then M bisects the third side. So what is that one? we learned the converse midpoint theorem also. So when we are telling the midpoint theorem, it is parallel to the third side and a half of it. But when we are saying the converse criteria, one side it will be midpoint, another criteria is that it should be parallel to the second side, then it bisects the third side. So both the theorems are important. Practice the proof, and both the theorems we can see that ASA or AS criteria only we are using. So don't confuse the idea of proof. So practice more and learn the theorems, because this theorem statement can also be asked for exam because the name is there. So state and prove midpoint theorem, state and prove converse midpoint theorem, like that it can come. So practice more. With this today's class I am winding up. Thank you.